delve deeper a little bit into lists. Let's start with something we already are familiar with. So let's create a variable that is a list or list type. So you can call it my list if you want. And we're going to make it equal to a couple things here. So 2, 3, 8, and 9. So it's got these elements. Now, the question is, notice I put numbers here. Do they always have to be numbers? And do they always have to be integers? No. You could have something like this. My list 2, if you want, equals, and that would be maybe float numbers, 2.3, comma, 7.8. So they don't have to be integers, and 9.0. What else? Well, they could also be strings. So my list 3, we could have it where we could have something stored in it like this. Oops. Put a bracket. So without a bracket, it's not going to work. So you got to make sure you have a bracket. Okay. Henry. And that's the string that's stored as an element right there, comma, and Dolores. And then make sure you close the bracket. Okay. Okay. So far we have 3 lists, but they're pretty much consistent. They're all the same data type within the same list, right? So 2, 3, 8, 9 are integers, 2.3, 7.8, 9.0 are floats, Drew, Henry, and Dolores are strings. Do they have to be? Can we have a mix? My list 4 equals, and let's put 4 here. Let's put a string. Let's put a number which is an integer. Fine. Let's put something that's a float, 6.34. So you as a float, not a string. There you go. And that is perfectly valid. So in other words, a list can be heterogeneous, which means it does not have to have always the same data type as its data members. It's just a matter of design. What do you want to store in it? The key here is being able to access these items in the list and being able to eventually update the list in terms of adding items, removing items. So we're going to do some of that. But before, let's see if we can traverse the list. And as I mentioned before in the previous lesson, in this one, we're going to cover some looping. And we're going to start with a while loop and then eventually move on to for loops. So before I do a for loop or a while loop, to access any of these, I need to know how far I need to loop, because you have a finite numbers of items within a list. Let's go ahead and try to figure out my list itself. Well, there are ways to figure out what is the size of that list, and then we can control the loop based on that size. Now remember that each item in my list, the first item at the top, 2 is at index 0, 3 is at index 1, 8 is at index 2, and 9 is at index 3. That's going to be very important. So we have 4 items, but the last item is at index 3. So it's always the size minus 1. Keep that in mind. Well, first of all, can we figure out the size based on a list? Sure. Well, let's find out. Let's call it S1. And we're going to make it equal to len. This is a function, by the way. And then we're going to put in it my list. And let's see what that yields. I'm going to go ahead and print S1. Size of my list equals, just so you can see what that looks like. All right, so let's run this for a second. As you can see here, there are 4 items, right? So size of my list has 4 items. 1, 2, 3, 4. However, this one is at index 0, this one is at index 1, 2, and this one is index 3. So if you have to traverse it based on the size value to control our loop, we have to really pay attention to how far should we go. Well, let's see how we can do this. Now, let's say we have a counter and we set it to 0, right? And then, while the counter is less than S1. Aha. Strictly less than S1, not equal to S1. So as long as it's less than S1, what can we do? Let's go ahead and print each number by itself. So print, and then we're going to type my list, and then we're going to put counter here as the index. So think about what's going to happen to counter. Well, if we don't do anything, counter will remain at 0 because you set it to 0. The first time around, yes, indeed, this is true. Then what's going to happen, it will keep on printing 2 forever. That's called an infinite loop. You need to do something to make this condition go to false. Right now, we know it's true. Counter, if it's 0, it's definitely less than 4. So in other words, you're going to be executed this line anyway. So how can we get out of there? Well, you need to increment counter. So counter, you're going to increment it by 1. Now, this is the formal way to do a counter, is to write counter equals the previous counter, right? Or the present counter plus 1 equal the future counter, if you want to look at it that way. So by the time you go back and reevaluate the loop, so if you started at 0, so 0 plus 1, the loop now is 1 less than 4. The answer is still yes. So, however, your index now is 1, no longer 0, and etc. So let's go ahead and run this for a minute. And there you have it. So we have size of my list is 4, and we were able to step through each item of the list. Can we do the same thing with my list too? Well, reset the counter back to 0, because by the time you get out of this loop, and if I try to print counter, if I'm going to use counter again, just for giggles, so you can see what it's equal to, and I'm going to put counter here. By the time I get out of the loop, let's see what counter is equal to. So counter is 4 now, right? So you're going to have to reset it to 0 if you want to loop again into inside of another list. Remember here, the counter equals 0. You are priming the loop or the while loop, so the condition is always true to begin with. So we're going to reprime the loop by setting out counter equals 0 again, and then we're going to do a while loop now. Counter is less than. Now, instead of typing S1, S2, we're going to go ahead and evaluate the length, len, straight up of my list 2. Aha. So can we do the same thing we just did before? So yeah, absolutely. So we can go ahead and do my list 2. We want to see every item, and we're going to put counter as an index. Now, do not forget that you actually need to increment counter. Now, counter plus plus. If you were doing C++, this would be the way to do it, but we're not. We're gonna, you could do plus equal 1, right? This is similar to saying this. So this is a shorthand for what we just did. So this is an accumulation. Accumulate counter by adding 1 every time we encounter this. So I'm abbreviating some of the code now. So whatever you saw on line 13 can be abbreviated in this manner. Okay, well, let's see if we actually can step through my list 2. So let's go ahead and run it. And sure enough, 2.3, 7.8, 9.0. Now remember, you had only 3 items in there. And it stepped in just fine. Now, if you make a mistake and you make less or equal, for example, now we're going to get an error, because you're going to be stepping out of bounds or outside because you went beyond where 9 is. You went over here and there's nothing in there. And that's where you're going to get an error which says list index is out of range. Makes perfect sense. So you have to be really careful with your comparisons while you're doing this loop. So the counter has to be strictly less than the length. Why? Because you're starting at page 0 or index 0. So if you have 3 items, the last item will have index 2. Okay. All right. Well, let's do my list 3 again. Let's see if we get it. So again, you need to reset counter to 0 if you're doing a while loop. Okay. And while counter is less than len, the length of my list 3. And let's just double click on that. And we're going to do the same thing. So print. Then we can make it fancy. We could say name. And then here, you're going to put my list 3 counter. So you are referencing that index. And then make sure you're incrementing the counter. Otherwise, you will be stuck there forever. So plus equal 1 is a shorthand for incrementation. All right, well, let's see if we can get that to work. And there you have it. Name Drew, name Henry, name Dolores. So as you can see here, you need a couple things. You need to prime the loop. Next, for the while loop, you need to evaluate the condition. What condition? Is counter less than the length of my list 3? If it is true. And then here, this is the body of the loop. Both of these are part of the body of the loop. These two are part of the body of the loop, but this one in particular is what we call the loop control. Without it, you'll be stuck. Now let's suppose we didn't do anything, like counter plus equal 1. Let me go ahead and do that. Watch what happens if I comment it out. And I totally forgot, for example, to increment counter. So watch what happens. And it will keep printing the first item because counter never incremented to 1. Okay? And it's looping forever. This is what we call an infinite loop. So I'm going to stop it right there. As you can see here, we get an error because I broke the program while it was running. Okay? So let's bring it back. And this will be the proper way to have your code. So as you can see, it steps through Drew, Henry, and Dolores. The condition now is no longer true. You're no longer going to execute the body of the loop. The body of the loop for all these while loops are 2 lines, the print and the counter incrementation, which is your loop control. Okay, so lesson learned. Lists can be a series of the same data type. They could be floats, integers, or they could be a mixture. Like this one has a string, an integer, and a float. Okay? And using a while loop, you have to take into account that you need to prime the loop. You need to evaluate, if your counter or whatever you're using to step through using the index, right, is less than the length of the list. And as long as it's less than the length of the list, go ahead and execute the body of the loop. In this particular case, the body of the loop wants to print the content of the list based on its index. But make sure that you're incrementing the index accordingly, so that way you are stepping through the whole thing until the condition is false and you're out. All right, so our next exercise or lesson, I'm going to introduce you to the for loop, which is really a form of a while loop, but much more compact and much more user-friendly when it comes to data structures of this nature. Okay, I will see you then.